Hello students, welcome to the session. In this session, we will see chapter 3. This includes effective stresses, permeability and seepage through soils. Total 3 topics are included in chapter 3. And for GATE exam, if you concern the GATE exam, on an average of 3 to 4 marks, may appear from this topic. How much? For GATE, 3 to 4 marks from this area. Is it okay? So we will see. Now you can imagine how important the topic is, and moreover the effective stresses and permeabilities, these are the 2 topics we further use in our subsequent subsequent chapters. Like next we have consolidation, we will use the effective stress concepts in consolidation. After that we have shear strength, we will use over there. Next we will use in foundation engineering. So whatever the subsequent topics we may enter, we will use these effective stress concepts over there. So that's the reason this is a major and important subject in soil mechanics. Is it okay? Now we will see stress. What is stress? Stress. It is resistance offered by the body. It is the definition from strength of materials. What I am taking is resistance offered. Resistance offered by a body without deformation. When here body may be material also, by a body or any material it can be, without deformation, when it is subjected for external load. I'll tell you simple example of stress where you can easily understand what is it. Yes? If somebody comes and slap you, slap on your face, what happens? Yes? What happens? What will be the reaction immediate? Is there any resistance? Direct resistance from your face? No. Resistance will be in the form of immediate slapping on him from your end. Then you will realize that you feel some pain here. That pain, whatever the pain you feel here, that is what is stress. Resistance offered by the body. The slapping, whatever the slapping force on your face, if the slapping force doesn't bear by your skin or doesn't bear by your face, then it is subjected for some stress. Resistance, internal resistance offered by the body against the external force. And deformation means after some time you will see the impressions, hand impressions, and you can feel the variation in your skin. That is deformation. Yes? Or else if somebody pinches you, pinching is an external force. Due to pinching, we can feel some pain wherever in the pinched area. That is what is stress. Simple to understand. Yes, resistance offered by a material or body against the external force without deforming is stress. Is it okay? So we have in strength of materials, we will consider concrete, steel, and we have different materials where we will calculate stress. In strength of materials, we will calculate stress, normal stress, bending stress, shear stress, and in thin cylinders we calculate circumferential stress, hoop stress. Yes, like that in strength of materials, every topic we will be learning stress. Yes, the same stress now we are applying on soil. If you recollect our soil mechanics, application of principles of solid mechanics and fluid mechanics, that application of principle from solid mechanics is stresses and strains. That's what we are bringing from strength of materials and we are applying on soil. Now, mathematical formula for stress. What is its mathematical formula? Yes, it is load upon cross-section area. Now, instead of load, I will consider weight upon. What I will do? Weight upon cross-section area. This is what the stress mathematical formula. Stress sigma is equal to, I am considering weight by cross-section area, weight upon cross-section area. Now, what we will do? I will take a soil layer. I will take a soil layer having unit weight gamma, and its depth or thickness is Z. Its depth or thickness is Z. I am considering unit weight of soil as gamma and thickness or depth is Z. Now for this, how the formula will vary, we will see. If you recollect, unit weight of soil gamma is equal to unit weight of soil gamma is equal to, what is it? Unit weight of soil gamma is equal to weight upon volume. Weight upon volume. Therefore, weight can be written as gamma into volume. Weight can be written as gamma into unit weight of soil into volume. Now, I will replace weight. Therefore, stress is equal to, I will replace weight with gamma into volume upon area. Gamma into volume upon area. Now you see, this is Z, depth is Z. On the other hand, I have unit width, unit length. Now 1 into Z, this will be our volume, or else gamma into area into volume, area into Z, thickness of depth of soil upon area. Is it okay? Now stress will be equal to gamma into Z. Therefore, sigma is equal to gamma into Z for soils. This is the new mathematical formula for stress. For the soil having thickness Z, for the soil having thickness Z, stress can be written as unit weight of soil into thickness of soil. This is the new definition for stress. Is it okay? Yes, you can copy down. I'll give 1 minute of time. Yes, shall I raise? Now we will see total stress definition in soils. What I will do, we will see total stress definition. First definition in effective stress is total stress, sigma. This total stress sigma, it is the stress due to the sulfate of soil, and if any overburden pressure acting over it. I mean stress due to sulfate of the soil, as well as if any overburden pressure acting on it, both combinedly will give total stress. Now you can calculate this total stress at any point in the given soil section. You can calculate at any point. Let us take, I am taking at any plane, or instead of point, at any plane. I am considering this plane. Now at this plane, I will assume some section 1-1. I will assume some section 1-1. At this top of the plane, what will be the total stress? Means here there is a surcharge of Q, and this is the only acting stress at the plane 1-1. This will be the external surcharge it was, due to which stress will act at 1-1. When you come to plane 2-2, bottom plane, this is plane 2-2. Now total stress will be equal to surcharge, external applied pressure, plus the sulfate of the soil. Both combinedly will give total stress at 2-2. Now you can find out the stress using whatever the formula we have. Stress at point, at any plane, given by unit weight of soil into thickness of soil. Now to calculate here unit weight of the soil, we will consider the corresponding unit weight of the soil. If there is water content available, water table available here, then it will be gamma sat. We will consider gamma sat. If it is in dry state, it will be gamma d. We will consider gamma d. So whatever the soil condition is in, we will consider that unit weight multiplied by the thickness of the soil, where we have to calculate stress. Is it okay? Now, so how we can write the definition? Total stress is the stress due to the sulfate of the soil and overburden pressure which is acting on the soil. Both combined will give total stress and denoted by sigma. Yes, you write down total stress sigma. Total stress sigma. Total stress in soil. Total stress in soil is due to its self weight, and overburden pressure acting on the soil. Overburden pressure acting on the soil. This is what is stress. So here it will be, if I have given only one soil, it is single, it is very easy. But if I give two different soils, let us assume it's a stratified layer, I mean different soil layers. This is soil 1 whose thickness is Z1 and whose thickness is Z2. These are the two thicknesses of the soil. Now here the unit weight of soil for soil first layer is gamma. Here it may be gamma sat if water table is located here. Now for this case, if this is the case, so top layer, bottom layer, this having different properties, this having different properties. For different properties, what we will do, we will consider one more plane here. So I will consider this as plane 2-2. This will be now plane 3-3. It will be plane 3-3. Now you can see here what we can see. So while calculating stress at 1-1, it is the surcharge. At 2-2, surcharge plus stress due to top layer. At 3, surcharge plus stress due to top layer plus stress due to bottom layer all together. So it is a cumulative of stresses. While calculating what we do? We do cumulative of stresses from top to bottom in total stress calculation. Yes, this is about total stress. Next one. Pore water pressure. Pore water pressure, important amma. Try to understand. Pore water pressure or simply pore pressure U. Pore water pressure or pore pressure U. See here, if water table comes into picture, if water table comes into picture, if this is the existence of water table, if water table comes into picture, what will be the soil condition? Saturated. So total one soil only? Saturated. Let it be total one soil, it is saturated. Now we know that whether water is a compressible material or incompressible material. Yes, whether water can be compressed. Can we compress the water? No, we cannot compress the water. Water is incompressible. Water is incompressible, as well as soils are also incompressible. Soil solids are incompressible. Water is also incompressible. This soil solid definition we have seen the first session, that our definition for soil, unconsolidated discrete solid particles. So it's an unconsolidated means incompressible. Now here water also being incompressible. Now what happens here? Due to presence of this water table, soil will be in saturation condition. Saturation condition means this is what it looks like. Try to understand what I am going to explain now. These are the soil grains which are present in our soil. Now due to presence of this water table, what happens here is all voids are filled with, here all the voids are filled with water. Now all voids are filled with, the gaps between the soil grains are filled with water. This is water. Now just now I have said that total stress is cumulative of calculation of stresses from top to bottom. So that means simple, it is a transfer of stress or load from one granular to other granular, one granular to other granular. This is what is stress. Now what happened here? In due process of transferring of stress from top granule to bottom granule, in due process of transferring of load or stress from one granule to other granule. Now if there is no water means nothing happens, everything is good. But here due to presence of water, while transferring this load or stress from top soil grain to bottom soil grain, it is obstructed by the water particle. So this is what happens practically. It is obstructed by the water particle. Now you tell me, both the soil grains, this top soil grain, bottom soil grain, they will apply equivalent and opposite force on each other. So due to the water as a median present in between these two granules will obstruct that force. Obstruction means simply what he will do, this is soil granule, this is soil granule. Now water is present in between these two soil granules. What happened? He will apply a force. He will apply a force that is opposed by the bottom granule, but this water doesn't allow for this soil granule to pass the load immediately. Reason is, to pass load from here to here, water must get compressed. Water must get compressed. Immediately water won't get compressed. Reason is, water is incompressible. Instead of getting compressed, it will apply, due to this external load applying on water, it will apply anti-pressure or opposite pressure, or we call it as neutral pressure. What happens? See here, this is the downward stress or downward load which was acting due to the soil grain. Now, this is opposed by the water. Reason is water is being incompressible and it won't carry any load initially. Instead of carrying load or instead of carrying stress, water will apply anti-pressure on the source of soil or stress of our soil. Now what happens? At every point this will happen. Yes, there will be a anti-stress or anti-pressure or neutral pressure that is acted on our soil at every junction, amma. So here also it will act. Here also it will act. But how much it will act is important. So it is difficult to calculate layer by layer or void by void. Therefore, how we do is, what is the pressure head that is causing water pressure on our soil? How do we calculate? By calculating what is the pressure head. To know that, what we will do, we insert a piezometer at wherever we want the pressure head. Wherever we want pressure head, because the pressure applied by water is P. Water applied pressure is P, that is equal to unit weight of water into pressure head HW or piezometric head of water HW. Now to note this HW, what we will do, we insert a piezometer at wherever the depth or wherever the point we want to calculate our pressure head HW or piezometric head. Now for that sake, I want to calculate somewhere here, let us assume. I want to calculate somewhere here, or I want to calculate the top. I want to calculate what is pressure head at the top. For that sake, I will insert a piezometer at the top. Once you insert a piezometer, what water level shows in the piezometer? That is our piezometric head or pressure head causing pressure. So this will be the 0 will be the pressure head if I insert it at the top. Why? Because here itself water table is available. So that shows 0 pressure head. Similarly, if you insert a piezometer at the bottom of soil, if you insert a piezometer, now water levels which is shown in the piezometer will be this one. And how much it is? Just now we have written, it is Z. It is Z. HW will be Z. HW given. HW at the top 0. HW at bottom is Z. Thus how we calculate thus how we calculate pore water pressure U. I have written here P, I have simply written as water pressure. Now we'll consider that as U. This is what is pore water pressure or simply pore pressure. Yes, you write down the definition. So in writing definition, what we will do, this is the pressure which is transmitted by the pore water. Pressure which is transmitted by the pore water through their point of contact, not through their point of contact. Pressure which is transmitted by pore water is pore water pressure. Write down the definition for pore water. The pressure which is transmitted by pore water is called pore water pressure or simply pore pressure. Pore water pressure or simply pore pressure. It is also known as also known as neutral pressure. Neutral pressure, pore water pressure, pore pressure or neutral pressure, all are same. Yes. Next line, at any point in the given soil mass, at any point in the given soil mass, pore water pressure U can be calculated. Pore water pressure U can be calculated using equation U is equal to gamma W into HW. Yes, using the equation U is equal to gamma W into HW, wherein HW is piezometric head of water. Piezometric head of water at the given point. Piezometric head of water at the given point. Next, third one. Effective stress. Effective stress. Effective means after see, just now I have told that whatever the load that would like to transmit from one soil grain to another soil grain is being obstructed by the water. Thus, water applies its pressure. What is the water pressure? Just now we have seen U is equal to gamma W into HW. After water pressure, whatever the net force or net stress that is being transmitted by soil grains, net force or net pressure or net stress that is being by soil grains from soil to soil, after neutralizing by pore water only, after neutralizing. Why? Because just now I have said that this is as neutral stress or neutral pressure. What it does, it neutralizes the total stresses. What neutral stress do? It will neutralize the total stress. Whatever the total stress that would like to transfer earlier, it have been neutralized by water pressure or pore water pressure. So after neutralizing by pore water pressure, the remaining leftover stress in the soil, will transmit after neutralizing, will transmit from soil to soil, from soil grain to soil grain. How we call means the net pressure that is being transmitted by soil grains through their point of contact is known as effective stress or intergranular pressure. The net pressure that is being transmitted by soil grains through their point of contacts is known as effective stress. Yes, this is what is effective stress. You write down definition of effective stress. The pressure that is being transmitted, the pressure that is being transmitted by soil particles, through their point of contacts, through their point of contacts, is called as effective stress. Is called as effective stress. Yes, it is denoted with sigma dash. Effective stress is denoted with sigma dash. Effective stress is also known as, you write down after this, effective stress is also known as intergranular pressure. Effective stress is also known as intergranular pressure. So, here what happens, it is difficult to calculate effective stress. It is difficult to calculate whatever the net net pressure that is transmitted by soil grains after fulfilling the needs of pore water pressure. It is difficult to calculate. Therefore, effective stress is calculated indirectly. How it is calculated means, here total stress sigma is equal to water pressure plus soil pressure. Water pressure we have written as pore water pressure U plus soil pressure we have written as intergranular pressure. Pore water pressure plus internal granular pressure. That is our total stress sigma. Yes, now we want to calculate effective stress or intergranular pressure, sigma dash. This is sigma dash. Therefore, effective stress sigma dash is equal to, how we can write, total stress sigma minus pore water pressure U. That is, effective stress sigma dash is equal to total stress minus pore water pressure. It's an indirect measurement. We don't have direct measurement to calculate effective stress. That's the reason we will calculate it indirectly using the known parameters of total stress and pore water pressure. Yes, you copy it. So now we will see this total stress, pore water pressure and effective stress for different soil, for different cases. We will consider some different soil cases and we will try to extract total pore water and effective stress for those cases. Yes. First, you put case 1. Case 1. Here, in this case, I will consider a simple soil layer having thickness Z, unit weight of soil being the gamma. For this condition, we will calculate what is effective stress at top. I will assume this as section 1-1, section 2-2. So calculate effective stress at 1-1 and 2-2. Calculate, here I'll write it. Calculate effective stress at 1-1 and 2-2. Okay. Now, I'll consider, this is the standard format, section 1-1, total stress sigma, at 1-1, here's the section. What will be the total stress sigma? See here, if there is any load or surcharge above section 1-1, yes, if there is, we'll stand at 1-1, let us stand at section 1-1, and if you see over 1-1, do you see or do we have any load or any surcharge? Yes, no. Once there is no load or no surcharge at this layer, total stress will be equal to 0. Next, pore water pressure. I'll simply write pore pressure U. Pore pressure U. Now you see here, do we see water table here? Yes? No, we don't have any water table. Pore pressure comes into picture when soil is in full saturation and water table existence is there. Now if there is no water table existence means pore water pair is 0. Finally, effective stress. Sigma dash total stress minus pore water pair, 0 minus 0 is 0. Now at 2-2, what is total stress? We are at 2-2. Total stress definition sigma is equal to unit weight of soil into thickness of soil. At 2-2, what is the thickness means? The total thickness of soil up to 2-2 is Z and unit weight of soil is gamma. Therefore, total stress sigma can be given as unit weight of soil is gamma, thickness of soil is Z. Therefore, I will write it as gamma Z. Now, since there is no water table, once again pore water pair is 0. What will be effective stress? Gamma into Z. This is what is the standard table and calculation. Now I will draw the diagrams. I will extend these lines. Yes, first total stress at top 1-1, what is the value of total stress? It is 0, 0. At bottom, what is the value of total stress at 2-2? It is gamma into Z. Gamma into Z. This is what is total stress diagram. Now, pore water pair At top 1 it is 0. At bottom also it is 0. Yes, top 0, bottom 0. This is pore water pressure diagram. Now, finally, effective stress. What is effective stress at top? 0. And what is effective stress at bottom? It is once again gamma into Z. It is gamma into Z. This is effective stress diagram. Total stress, pore water pressure, and effective stress for a soil having thickness Z. Okay. You copy down? Yes. We'll take case 2. Case 2, same. Calculate effective stress sigma dash at 1 and at 2 for the given profile. The profile is like this. Here it is. Thickness of soil is once again Z. Thickness of soil is Z. Unit weight of soil will be gamma sat. Why it is gamma sat? Yes, since water table is existed at ground surface. That's the reason I have taken as gamma sat. This I'll take it as plane 1 and this I'll take it as plus section or plane 2. Yes, same format. Finish this one. Here, same format. Section, total stress, sigma, pore water pressure, U, and effective stress sigma dash. Effective stress sigma dash. Now you see here. At section 1-1, do we see any total stress? At section 1-1, any total stress is on? Any load or surcharge or overburden pressure is there? No. Once there is no load, no surcharge, no overburden pressure, total stress will be always 0. You remember it. Nothing is there, then it will be 0. Yes, coming to 2-2. Now here, what is the unit weight of soil given here? Gamma sat. Thickness of soil up to 2-2 is Z. Therefore, it will be gamma sat into Z.